Good morning, everyone. This is Cinco. I wanted you to check out these wonderful whiskers. I'm thinking that these whiskers, which actually help the cat calculate the distance it is from certain objects, that the cat might just have some mystical geometry powers. And today we're going to be looking at finding some distances. So let's use a little inspiration from this wonderful cat Cinco and get started on learning. All right, so here we're going to look at today, how do you find the missing angles in right triangles? Missing angles, not sides. All right, so this is going to involve something new. Check it out. Have no fear, inverse trig functions are here. Okay, so you have a 30, 60, 90 triangle. Now, notice here, across from 30, of course, is your opposite, and the hypotenuse here. So we know that sine of 30 degrees is 1/2. All right, if you type that in your calculator, sine of 30, you get 1/2. Now, let's say that you only knew the ratio. All right, so what you have is some other keys on your calculator. You have the sine key, and then notice above it you have the sine to the -1. That stands for the inverse trig function. All right, so that means if you type in inverse sine of 1/2, then your calculator will tell you the 30-degree angle. So type that in your calculator. Make sure you can get that in there correctly. All right, so now we're going to practice finding the angles. All right, so let's look at number 1 here. All right, you have your right triangle. You are looking for the measure of angle x. So you're going to label your triangle. Across from x is going to be your opposite side. Across from the right angle is your hypotenuse. All right, so opposite and hypotenuse. All right, let's look up here. Let's write down SOHCAHTOA at the top. Better not misspell his name. All right, so opposite and hypotenuse, that is going to be sine. So we're going to start with sine of x. Sine of the angle is equal to opposite 15/24. Ooh, love having a fraction to reduce. Simplify your fraction. All right, so that, of course, dividing by 3 will give us 5/8. All right, so now we need to calculate the angle. So we're going to say x, the angle is equal to inverse sine of 5 divided by 8. All right, now take your calculator, type in second sine, the parenthesis comes up, 5 divided by 8, close your parentheses. And you are going to round to the nearest tenth. Okay, so that would give you 36.7 degrees. All right, now let's say you didn't realize that 15/24 simplified. You were rushing. Okay, I want you to go back and check and see what happens if you just type in inverse sine of 15/24. Okay? All right, so let's move down here to number 3. All right, so I'm going to find the angle first. The angle is x. Okay, so label the sides. Across from x is going to be your opposite side. And beside the x, this is going to be your adjacent side. All right, so opposite and adjacent, and come up here, is tangent. So we're going to start out writing our tangent of the angle is just equal to this ratio of the opposite side, 20, divided by 37. Okay, let me make sure that's 37. Yes. All right, so now we're going to look for the angle. So whenever you're looking for the angle, you have to use the inverse key. So inverse tangent of 20/37. Now, 37 is that prime number, so that's obviously not going to reduce. All right, so I'm going to pick up my calculator here. All right, second tangent. And 20 divided by 37, and I get 28.39. Okay, so rounding to the tenths place, that's going to give you 28.4 degrees. All right, now here's what I need you to do. I want you to come up and show me, after you've completed, numbers 2 and 4. Bring those up so I can check in and make sure you're doing okay on these. All right, we're going to squeeze in a new topic here. Angles of elevation and depression. So I want you to be able to have a really good picture of what's going on. All right, so I want you to imagine yourself floating in a boat. All right, out in the middle of, we might as well be in the ocean. All right, you're floating out there, and over here we have some land. And on the land there is this, what do you call these things? These really tall things. They usually have stripes on them. A lighthouse. Okay, so over here there's a lighthouse. It's a really good lighthouse. Loving this today. All right, so imagine you being out here in a boat. All right, look at this. Okay, let's put you in a little boat right here. There you are. Oh, you're so happy. You're so happy to be floating out here. Oh, I better give you some arms so you can help steer. All right, nice. Okay, so you're hanging out here. Let's give you a little hair. All right, so you're hanging out here in the boat, and you notice that you can look up and see the top of the lighthouse. All right, so if you're here in the boat and you look up, the face just got really scary, and you look up to the top of the lighthouse, okay? You will see the top up here. Okay, now what you're doing is you're creating an angle from your eye up to the top. Now, your eye, the angle that we're going to look at is compared to if you looked straight out at the object, okay? This has to be a horizontal line. Okay, so you have a horizontal line of sight, you look straight out, and then you look up at something. That is called the angle of elevation. All right, now take it a step further. Imagine you're up here on the top of the lighthouse. We're just going to put an eyeball up here. All right, so imagine that you're up here at the top, okay, the lighthouse guy. He's looking for people, okay? And he would have to calculate the angle at which he sees someone. All right, so what he's going to do to calculate his angle, he's going to look straight out, again, getting that horizontal line of sight, okay, straight out, parallel to this other line, of course. And then he's going to look down, looking down, okay? So from the horizontal sight looking down, this angle is called the angle of depression, okay? So imagine the depression, you're looking down, elevation, you're looking up. All right, so you get these two angles here, okay? Looking up, angle of elevation, looking down, angle of depression. So when we're going to be doing some word problems, you want to be really careful about whether you're looking up and looking down, and always drawing a horizontal line before you start anything else, okay? Drawing your horizontal line. All right, now, hopefully, you can also notice something about these horizontal lines. And these two angles, the angle of elevation and angle of depression, this should look pretty familiar to you. All right, so as a little bonus, if you can come up and tell me the names of these two angles when you're in what kind of lines these are going to be, and what you call this line right here, you might get a little bonus treat there. All right, a lighthouse keeper observes that there's a 3-degree angle of depression when he sees a ship. If the keeper is 19 meters above the water, how far is the ship from the shore? All right, so I want you to imagine you have a lighthouse, okay? You have, somewhere out here in the water, a little boat. All right, the lighthouse keeper, remember, is up here at the top of the lighthouse. It says there's an angle of depression. So the first thing you do is you draw your horizontal line of sight. And then, from this point, he is going to look down and sees the ship. So this angle between your horizontal line of sight and the boat is 3 degrees. All right, so it also tells you he is 19 meters above the water. All right, so here, then, you have to figure out how far is the ship from the shore. Okay, so this would be your distance x. All right, so notice since this is horizontal and this is vertical, then you could figure out this angle right here. All right, so 90 minus 3 is going to give you 87 degrees. All right, now, once you have this, you're going to label your sides. Across from 87 is your opposite side. Beside it is your adjacent side. All right, so that means we're going to get to use the tangent ratio. All right, so tangent of 87 degrees is equal to x over 19. All right, now we learned how to solve these yesterday. Multiply both sides by 19 and plug this into your calculator. All right, those cancel out, so x equals 19 times tangent of 87. All right, so for a final answer of 362.5 meters. All right, next example. The angle of elevation is measured 5 feet above the ground, so that's probably about eye level for someone, from a point 100 feet from a building. The angle of elevation to the top of the building is found to be 68 degrees. How tall is the building? All right, so we're going to pause. You need to draw the picture and then compare it to the picture that I draw. Stuart, it's 6. Alrighty, so let's see what we have here. You've got the building, you've got your person looking up at the top of the building. Draw your horizontal line of sight. Okay, you know that's 100 feet from the building. Alright, he's 5 feet above the ground. Alright, so you have this right triangle here. And, oh, right triangle. Oh my goodness, we get to use some Sokotoa here. Good morning, Stuart. That was a little weak. Give me a good morning. Wow, still weak. All right, opposite and beside this one, we have adjacent. All right, so opposite and adjacent is going to be tangent. So we get tangent of 68 degrees equals x over 100. All right, multiply both sides by 100. And let's see, 100 times tangent of 68, and you get x is 247.5 feet. All right, it says how tall is the building? All right, so you need to finish this problem by coming over here and noticing that that was measured from 5 feet above the ground. So we're going to add 5 to this for a total of 252.5 feet. All right, guys, good talking to you this morning. See you later.